Physics Grade 9 Advanced MOE Exam Term 3 2021-2023. Question number 1. Salma pulls a suitcase with a force of 50 Newton that is applied along the handle at an angle of 60 degree to the horizontal. How much work has Salma done after walking a distance of 15 meters horizontally? So she is applying a force of 50 Newton and the angle between force and the horizontal is 60 degree, that is given here. So angle is 60 degree and you are asked to calculate the work done. So the equation to calculate work done is work is equal to force multiplied displacement multiplied cosine theta. Work done is equal to force multiplied displacement multiplied cosine theta. Here force is 50 Newton. So 50 multiplied displacement is given here. She is walking a displacement of 15 meter. So 50 multiplied 15 multiplied cos. The angle between force and displacement is along this direction and force is acting along this direction, and the angle between force and displacement is this angle, that is 60 degree. So 50 multiplied 15 multiplied cos 60. You can do the calculation. 50 multiplied 15 multiplied cosine 60. So I am getting 375 joule. So this is the answer for the question number 1. Now we will move to question number 2. Salim ties a ball to the end of a 1 meter string and swings the ball in a circle. If the string exerts a 10 Newton force on the ball, how much work does the string do on the ball during? Here also you need to calculate the work done. So we have this equation, work done is equal to force multiplied displacement multiplied cosine theta. So in this, force is acting towards the center of the circular path, and here you can see the displacement will be along this direction. So the angle between force and displacement is equal to 90 degree. So in this question, angle theta, that is equal to 90 degree. If you rotate an object using a string like this, then the angle between direction of force and direction of displacement will be 90 degree, and the value of cos 90, that is equal to 0. As cos 90 is 0, this equation becomes 0, or the work done become equal to 0. So work done will be 0 if the angle between force and displacement is equal to 90 degree. So here 0 is the correct answer. So when you when you rotate an object like this as shown in this diagram, then the work done will be equal to 0 because the angle between force and displacement is equal to 90 degree and value of cos 90 is 0. Question number 3. A particle experiences a force that varies with position as shown in the graph. What is the work done by the force between x equal to 4 and x equal to 8? So here a force displacement graph is given. You can see a force on the y-axis and a displacement on the x-axis. So this is a force displacement graph. If a force displacement graph is given, you can calculate work done by finding area under the graph. Work done is equal to area under the given graph. Area under the graph. Here you need to calculate work done between 4 and 8. So area under 4 and 8 is this much area. So you need to calculate area, this much area. So this is a rectangle. To calculate area of the rectangle, you can multiply length into breadth. So length into breadth, that is the equation to calculate area of rectangle. This is equal to, here length of this rectangular area, that is from 4 to 6 to 4, right? So 4 to 8, length is 4 multiplied, breadth is given here, you can see here, this breadth, that is equal to 10. 4 into 10, that is 40 joules. So this 40 joule is the answer here. Question number 4. In a curling game, a player does work to a slide of stone of mass 2.5 kilogram. The mass of this stone is 2.5 kilogram and it was initially at rest. He exerts a horizontal force of 40 Newton on the stone over a distance of 1.5 meter, then releases the stone. What is the velocity of the stone at the point of release on ice surface? So you are asked to calculate the velocity of the stone. We have this equation of work energy theorem. According to work energy theorem, work done, that is equal to change in kinetic energy. Change in kinetic energy of the object. So here initial kinetic energy is 0 because the object was initially at rest. Then we can calculate work done. Work done here in this question, work done is equal to force multiplied displacement into cos theta. Here cos theta means theta is 0 degree and value of cos 0 is 1. So we will write F into D. So here F is 40, the force is 40 Newton, multiplied displacement is 1.5 meter. So this is equal to 60 joule. Okay, 60 joule is the work done. So we can write change in kinetic energy. The equation for kinetic energy is half mv squared. This change in kinetic energy, that is equal to work done, that is equal to 60 joule. So you are asked to calculate V here. So I will rewrite this equation, V squared, that is equal to, we will take this 2 to the other side of the equation. So it become 2 multiplied 60 and divided by this mass, and value of mass is given here. Value of mass is 2.5 kilogram, that is the mass of the object. So if you want to calculate the speed, so we will write V equal to remove this square, we will take square root here. 2 multiplied 60 divided by 2.5, that is equal to 2 multiplied 60 divided by 2.5 square root answer, that is equal to 6.928. So we will choose this 6.93. okay, 6.93 meter per second. Question number 5. Which of the following examples shows kinetic energy? Kinetic energy is the type of energy that is related to the moving object, or energy possessed by the moving object. Energy possessed by a moving object, that is called kinetic energy. Or we can say kinetic energy is the energy due to the motion of the object. The battery of light flash, so the light is not moving, so no kinetic energy, its kinetic energy is 0. If any object is at rest, its kinetic energy will be equal to 0. Only moving object will have kinetic energy. A river flowing down a hill. The river is flowing means the river is moving. That is why it will have a kinetic energy. So this example shows kinetic energy. Energy is stored in a bow and arrow. So here that the string is not moving, so there is no kinetic energy. The string is actually stretched, so there will be elastic potential energy, okay, not kinetic energy. Then if a golf ball is placed at the edge of the hole, so it is placed at the edge means the ball is not moving, so its kinetic energy is equal to 0. So only the flowing water has kinetic energy in this question. Question number 6. Which of the following equals energy divided by time required to this change? The energy divided by time, energy divided by time, that is called power. The definition of power is rate of change of energy or rate of doing work. So we can say power is energy divided by time or work divided by time, that is equal to power. So here energy divided by time, that is equal to power. Question number 7. A weightlifter lifts 300 kilogram from the ground to a height of 2 meter in 3 seconds. What is the average power generated by him? So the equation to calculate power is equal to work divided by time. So we know that how to calculate work done. Work done is force into distance divided by time. So if you are lifting an object, the force you need to apply, that is equal to weight of the object. So power is equal to force what that you need to apply is equal to weight mg multiplied distance divided by time. So here mass is 300 kilogram and the value of g, that is a constant, it will be always 9.8 multiplied the displacement moved is displacement, here it means height, that is 2 meter divided by time is 3 seconds, the time taken for this work, that is 3 seconds. So 300 multiplied 9.8 multiplied 2 divided by 3, that is equal to 1960 watts. 1960 watts is the power generated in this work. 1960 watts. Question number 8. A car engine uses a force of 29 kilonewton to power a car at an average speed of 7.5 meter per second. What is the average power of the engine? So we have this equation to calculate power. Power P is equal to work done divided by time. That is force into displacement divided by time. Force into displacement by time, that is equal to velocity or speed. So power is equal to force multiplied speed of the object. So we have two equations to calculate power. This is the first equation. Power is work done over time or force into distance by time. Another equation to calculate power is force into velocity. So if velocity or the speed is given, you can calculate power using the equation force into velocity. Force is 29 kilonewton. So 29 into 1000, because we need to change kilonewton to newton, multiplied speed is 7.5. Multiplied 7.5, that is 217.5 kilowatts. 217.5 kilowatts is the answer. Question number 9. A plastic bottle initially containing hot air is placed into a bowl of ice as shown in the figure. Which of the following statement is true? First one, the average kinetic energy of air particle decreases because when it is kept in the ice, the temperature decreases, right? Temperature of the air particle decreases. Temperature decreases means average kinetic energy of the air particles decreases. So this is the correct answer here. The average kinetic energy of air particles decreases because temperature decreases. A clinical thermometer is placed under the tongue of a patient to measure his temperature. What is the principle that the thermometer uses in measuring the temperature? So thermometer, the mercury inside the clinical thermometer absorb the thermal energy, that is heat, and it expand and it reach the thermal equilibrium. So change of state is not correct. Second law of thermodynamics not correct. First law of thermodynamics not correct. So thermal equilibrium. Every two objects in contact will reach thermal equilibrium. Thermal equilibrium means the thermometer reaching the same temperature of our body. Question number 11. Which of the following temperature equals absolute zero? Absolute zero means the 0 Kelvin temperature. Absolute zero is 0 Kelvin temperature. So when you express absolute zero in Kelvin, that is equal to 0 Kelvin. So this temperature is absolute zero temperature. If you express that in degrees Celsius, then absolute zero is equal to negative 273 degrees Celsius. And if you express that temperature in Fahrenheit, the absolute zero, that is equal to negative 459.67 Fahrenheit. So here 0 Kelvin is not given in the choices. Negative 273.15 degrees Celsius is not given in the choices. So this one, that is negative 459.67 Fahrenheit, is equal to absolute zero temperature. Question number 12. Heat energy is supplied at the same rate to the same amount of oil and water in similar containers. Which of the following explains why the temperature of oil rises more quickly than water? Because oil has less value of specific heat capacity. If a material has less value of specific heat, so its temperature increases faster. If we take example of wood and iron, so if you heat a wooden stick and an iron rod, the iron rod temper become hot faster because the temperature of iron rod increases faster. The reason is the specific heat for iron is less compared to the specific heat for the wood. If the specific heat is less, if the value of specific heat is less for a material, so it become hot faster, means its temperature increases faster. So the oil has smaller specific heat than water. That is why the temperature of oil increases faster compared to the increase in temperature of water. Question number 13. What do we call the heating caused by the motion of fluid in a liquid or gas due to temperature difference? So it is called convection. Example is boiling water. When you boil the water, you can see the water molecules move from bottom of the vessel to the top. So the water will move from the top to the bottom. So there will be a convection current. The water molecules will be circulating inside the vessel. So the transfer of heat or transfer of thermal energy due to the motion of the molecule is called convection. Question number 14. 1 kilogram of ice at 0 degrees Celsius is heated until it changes to steam at 100 degrees Celsius as shown in the diagram below. Why the temperature at process A and C is not changing even though heat is absorbed? The reason is at A and at C, the state means change of state occurs. At A, the solid ice changes to liquid water. At C, the liquid water changes to steam, means it is changing to the gaseous state. So during change of state, the temperature will not increase. The reason is the absorbed thermal energy will be used to overcome the forces of attraction between the molecules. So the heat absorbed or the heat is used to overcome the forces of attraction between the molecules during change of state. Change of state here means at A, the solid ice changes to liquid water, and at C, the liquid water changes to steam, means the liquid water is changing to gaseous state. So during change of state, the temperature of the material will stay constant, will remains the same, and the heat absorbed during that process will be used to overcome the forces of attraction between the molecules. Question number 15. What is the amount of thermal energy needed to change the state of 1 kilogram of a substance from liquid to gas? So the thermal energy required to change the state of to change state of a substance from liquid to gas is called heat of vaporization. Heat of vaporization is the thermal energy required to change the state from liquid to gas, and heat of fusion is the amount of thermal energy required to change the state from solid to liquid. Question number 16. A block of metal of mass 5 kg requires 3.15 times 10 to the power 5 joule of thermal energy to change its state from a solid to a liquid at its melting point. Which of the metal listed in the below table is this metal? So in that table you can see different values of heat of fusion and heat of vaporization given. So here solid is changing to liquid, so here we need heat of fusion. So each metal has a specific value of heat of fusion. So if you are able to calculate the heat of fusion of the material mentioned in the question, then you can check whether it is equal to the heat of fusion of gold, silver, lead or mercury. So we know that the equation to calculate heat of fusion, we have this equation, okay, Q is equal to mass multiplied HF, where HF is the heat of fusion. So in this question we need to calculate heat of fusion. So I will rewrite this equation to calculate heat of fusion. HF, heat of fusion is equal to Q divided by M. Here Q means how much thermal energy is absorbed by the material. So this metal of mass 5 kg is absorbing 3.15 times 10 to the power 5 joule of thermal energy divided by mass of the object, mass of the metal. So here mass of the metal is 5 kg. So divided by 5 kg. So we will get Students, you can also calculate and check your answer. 3.15 times 10 to the power 5 divided by 5. So I am getting 1, 2, 3, 4. 6.3 times 10 to the power 4. 6.3 times 10 to the power 4 is the heat of fusion. 6.3 times 10 to the power 4 joule per kilogram is the heat of fusion of this metal. So we will check what will be the metal. Will it be gold, silver, lead or mercury? You can see here the heat of fusion of gold is 6.3 times 10 to the power 4. So this metal must be gold. Question 17. The diagram below show the change of state when thermal energy is added to 1 kilogram of ice starting at 243 Kelvin and continuing until it becomes water vapor. What is the specific heat of water? So specific heat of water, it's a constant value, that is 4180 joule. So this is the value of the specific heat of water. So you can use the equation also to calculate, means you can use this diagram to calculate specific heat. You will get the same answer. So this much energy, so energy supplied, that is equal to the difference of these two, that is energy supplied Q is equal to 813,700 minus 395,700. So energy supplied, that is equal to 813,700 minus 395,700, that is 400, sorry, 418,000. So this much energy is supplied. So during that the temperature difference is this much, is the temperature difference. So specific heat, that is equal to Q divided by mass is 1 kilogram into change in temperature. So here 41830 divided by mass is 1 kilogram and change in temperature is 373 minus 273, that is 373 minus 273, that will be equal to 100. So these two zeros cancelled, so you will get 4180 joule per kilogram degree Celsius. Okay, that is the value of the specific heat capacity of water. Question number 18. What is the change in thermal energy of a system when a total of 150 joule of heat is transferred out of the system and 159 joule of work is done on the system? So we have first law of thermodynamics. First law of thermodynamics states that the change in thermal energy of a system, that is equal to heat minus work. So here, what is the change in thermal energy of a system when total of 150 joule of heat is transferred out from the system? So if heat is moved out of the system, that heat we will consider as negative. So Q is negative if the heat energy is moved out of the system. So I will write negative 150 minus work done. So here 159 joule of work is done on the system. So work done on the system will be negative and work done by the system is positive. So here work is done on the system, that is why work done will be negative. So I will write negative 159. So negative 150 Minus minus will be plus 159. So we will get 9 joule. So the internal energy of the system is increased by 9 joule. Thermal energy increases by 9 joule. Question number 19. Figure below shows a student's thumb pressing during pin with a force of 15 Newton. So he is applying 15 Newton force over an area of 0.01 centimeter square, and you are asked to calculate the pressure. The equation to calculate pressure is force over area. All the equations will be given with the questions. And here at the beginning of the video, means first page of this PDF document is the equations. So those equations will be given with each question, and this pressure equation and all the equations we have used in the previous questions all will be given with the questions in the exam. So pressure is force over area. Here force the boy is applying is 15 Newton. So 15 divided by area is 0.01 centimeter squared. Centimeter squared is not the SI unit of area. SI unit of area is meter squared. So we need to change centimeter squared to meter squared. To change centimeter squared to meter squared, you need to multiply by 10 to the power negative 4. So 15 divided by 0.01 times 10 to the power negative 4, that is equal to 1.5 into 10 to the power 7 Pascal. 1.5 times 10 to the power 7 Pascal. Pascal is the SI unit for pressure. Question number 20. An amount of air is kept in a cylinder with a piston under constant pressure of 100 kilopascal. So pressure is constant. Here volume and temperature is changing. At a constant pressure, volume is directly proportional to temperature. That is Charles' law. So we can write V1 divided by T1, that is equal to V2 divided by T2. So here volume is given, instead of that length is given, and we are asked to calculate what is the final height, H2 we need to calculate. So here for volume I will write cross-sectional area into H1 for volume 1, and divided by T1, and cross-sectional area into, for volume 2 I will write cross-sectional area A multiplied H2, that is the second height, final height, divided by its temperature in Kelvin, T2. So this area and area will be cancelled. So our equation become like this. H2 divided by T2 means final height divided by final temperature, that is equal to initial height divided by initial temperature. We are asked to calculate the final height, that is H1 into T1, H1 divided by T1 into T2. So here what is the value of the initial height? Initial height is, you can see it is given here 20 centimeter. Initial temperature is 300, final temperature is 400. So 20 divided by 300 multiplied 400. 20 divided by 300 multiplied 400, that is equal to 26.667 centimeter. So we will choose this 26.7 centimeter. A sample of argon gas of volume 0.05 meter cube A sample of argon gas of volume 0.05 meter cube at a temperature of 273 Kelvin under a pressure of 101.3 kilopascal. What is the number of moles of argon atoms in this sample? So here to calculate the number of moles you can use the ideal gas equation. What is ideal gas equation? Ideal gas equation is PV equal to nRT. In this equation, P is pressure, V is volume, N is number of moles, R is a constant called universal gas constant, and T is temperature. You are asked to calculate N here, that is number of moles. So if I rewrite this equation, number of moles is equal to PV divided by RT. P is the pressure, that is 101.3 into 10 to the power 3 because we are changing kilopascal to pascal, and volume is in meter cube, so 0.05 divided by R is the gas constant, its value is 8.31, that will be given with the question, multiplied the value of temperature is 273 Kelvin. One 101.3 times 10 to the power 3 multiplied 0.05 divided by 8.31 times 273. So I am getting 2.23. So here number of moles is equal to 2.23. Question number 22. The figure shows a tank that supplies water to a house. What is the pressure at a point X? What is the water pressure? Okay, water pressure at X at the bottom of the tank. So the equation to calculate water pressure or liquid pressure is equal to H times rho times G, where H is the depth and rho is the density and G is a value of gravity, that is 9.8. So here depth you can see, you want to calculate water pressure at this point, and this point is at a depth of 4 meter from the water surface. So 4 multiplied density of water, that is 1000 kilogram per meter cube, and 9.8. 9.8 is the value of G. So 4 multiplied 1000 multiplied 9.8, that is equal to 3.92 times 10 to the power 4. So this is the answer. 3.92 times 10 to the power 4 Pascal or Newton meter square, Newton per meter square. Question number 23. A figure shows a hydraulic system. If a force of 12 Newton is exerted on the small piston, what is the output force on the large piston? So hydraulic system equation is F2 divided by A2, that is equal to F1 divided by A1. So here F1 is the force that we are applying on the smaller piston, and A1 is the cross-sectional area of the smaller piston. F2 is our output force. How much is the force acting here on the larger piston, and A2 is the cross-sectional area of the larger piston. So we want to calculate F2. F2 is equal to F1 divided by A1 into A2. Here F1 is 12 Newton and area is 10. Multiplied A2, the value of A2 is 50. So here this 5, right? So 60, okay? When you do the calculation, you will get 60 Newton. So 60 Newton is the available force, act means the force acting on the larger piston. Question number 24. When a ball with a mass of 0.25 kilogram was submerged in a cup of water, it remained in the middle of the cup. So it remained in the middle of the cup means the downward force, that is its weight, is equal to its upthrust, means the buoyant force. So here the buoyant force is equal to weight of the object. That is why it is staying at the middle of the water. So buoyant force we will calculate mg, right? M is 0.25 and g is 9.8. So here the value of buoyant force is equal to 0.25 times 9.8, that is 2.45 Newton. We are asked to calculate what is the volume of the ball. So we have the equation for buoyant force. V means volume of the object. Here object is ball, volume of the ball multiplied density of the liquid into G, that is equal to the buoyant force. Here value of buoyant force is 2.45. So you are asked to calculate the volume of the object. So volume of the object V equal to 2.45 divided by this density and G. The value of density is, you can see here, 10 to the power 3, that is 1000. And the value of G is always 9.8. So volume of the ball is 2.4 divided by 9.8 multiplied 1000. So I will change this into standard form. 2.45 times 10 to the power negative 4. So 2.5 times 10 to the power negative 4 meter cube. So this is the last question here. The figure shows same wooden block submerged in 3 different liquids A, B and C. Which of the following statements is correct about the densities of these liquids? So here you can see the 400-gram object is completely immersed in this liquid. So which means the density of this liquid is the smallest, and this has the highest value of density. So we will choose this one, density of liquid A is less than density of liquid B, and that is less than density of liquid C. Because if the density is less than the density of the object, then the object will be completely immersed. It will sink in that liquid. It will go down to that liquid. So now we have discussed all 25 questions from the Term 3 examination of grade 9 advanced physics in 2022.